Thank you, Lisa and Maria. Um, so, I, so I'm going to talk about my life story, more or less, of how I got into my subject and how my research goes. And so it'll be like a story. Uh, so, so I want to describe how my research life has gone on and how collaboration has been very important in that, and how that has affected my teaching in some ways. To start, let me begin with some background. So I'll start from the beginning, from my elementary school experiences. So I went to elementary school in Chennai, India, and when I went to school, a long time ago, we had slates. We didn't have paper and pencil in the school, at least elementary school. We were supposed to use slates. So I had like a bag, I put the slates and go to school with it. And so one of the things I remember about this elementary school, it's a small elementary school, was that there was a class called, if you translate it into English, it would be called Mind Mathematics. So in that class, what you were supposed to do is sit with your slate, and the teacher would stand in front of you and describe a problem. It was just like, third standard or something like that. And so it would be something like what you would call a word problem these days, so some story problem. And then you should listen to this problem. Then you would be given about maybe 2 minutes. So think about the problem and solve it, and write the answer on the slate and put it down, face down. And then the teacher will give you this next problem. Stand there and describe this problem. You listen to it. Then you're given some time, you solve it, and write the answer and put the slate down. So I really enjoyed this class. And what this class taught me was to be able to listen to somebody, carefully listen to what someone says, and take in all the information, and then process it in your own head and work it out and solve the problem. So that's something that stayed with me all these years, even so I can blame the fact that I'm a bad note taker on that class. And so then I went to my high school, which is also in Chennai, India, not far from where I went to elementary school. It's an old school, it's more than 100 years old now. And there I got interested in studying both mathematics and physics, more physics than mathematics. One of the teachers got me interested in physics. So, and the thing about the schooling I remember is that it's kind of different now in India, but at that time, so we had, was an old British system, so we had only one exam at the end of the year that determined everything. So, and there were books, but people didn't really pay that much attention to them, so you went to class, and you may find out other books, so people would tell you about it, and you studied with your friends. So you discussed things with your friends, and at least the ones who passed. So we would discuss things with our friends and prepare for things, and everybody helped each other because so it's not a competitive setup. So basically, what you got in the final exam was your grade. So, and the final exam was made up by some unknown person, not somebody from your school. It was some centralized examiner who made up the exam, and every school in the city took the same exam. And we knew the syllabus, and the person knew the syllabus. So your job was to make sure that you really understood the various subtleties of this subject, and you were prepared, and hoped that the questions asked were relevant to what you studied. But and so people just everybody wanted their friends and other people to succeed. So everybody just helped each other. So there was already a lot of collaboration going on. So I was used to studying in a collaborative setting right from that time. So then I wanted to study physics, but my parents convinced me that I should just do too dangerous because I may not get a job. So they told me I should study engineering. So I went to College of Engineering, Guindy, which was the only college in Chennai at that time. Now there are probably about 100 of them. So that's also an old school. That's the first engineering college in southern India. And there, it was a 5-year program. So there too, there were lectures. And there was no fixed textbooks. So they suggested some textbooks. And you could go to the lectures if you feel like it. So it's kind of like that's the British style stuff. So lectures were you're not required to go to lectures. It's up to you. You go to the lectures. And, but you know, most of us did. We thought we learned something. And the main studying was done in the library. So we would go to the library and talk to each other and find out what were the good books. And there's a bunch of books that were good. So we'd go find them. We couldn't afford to buy them. They were all usually books from England or US, which are expensive, but they were in the library. So we'd go to the library and get together and study it and discuss it. And again, everything was determined by this one final exam at the end of the year. So everybody prepared together, and we all worked with each other, helped each other, learned from each other. So there was sort of like, it was nice. It was a cohort of, intellectual community, just like we all were interested in this stuff, and we would talk to each other and teach each other. So sort of collaboration was a natural thing for me. I enjoyed doing that. So then I finished engineering, and I wasn't that happy with it. So I wanted to study physics, and it wasn't possible in India. Since I studied engineering, I had to stay there. So I came to US to study physics. And the place I came to was, doesn't exist anymore. Graduate School of Science. Yeshiva exists, but not the Belfer Graduate School. And I came to study there because I was interested in foundations of physics, things about more philosophical questions in physics, and that was one of the few places where people were really studying. And Einstein used to be, Dirac used to be there. Einstein's student was one of the professors there. So it was a small school, but it had amazingly great people in it. So if you go there, then classes were small, and you can interact with your professors very easily, and these were giants in their field, so it seemed like a good place to go. So I went there, and I had a wonderful time there. And halfway through there, I kind of lost my interest in foundations of quantum mechanics. So I had my doubts. So I decided to work in statistical mechanics. And that's my advisor, Joel Leibowitz. And he asked me to, he didn't look like that when I started working with him, his current picture. And he's now at Rutgers. And so we started working on statistical mechanics. And education there was also interesting because there, the classes were very small. For example, the classes with somewhat traditional classes, and the class with Joel was very different. So it would be in his office. So we would gather, the graduate students will gather in his office, and he'll be on the phone or talking to somebody. Then they'll come and he'll say, okay, now what were we talking about last time? And then he just knew the stuff inside out. So he just start from where we left off and start telling us things. And so basically, he wasn't using any textbook or anything. He was telling you the subject. And so we learned from him. And it was challenging too, because he was, a serious researcher. And so he would kind of throw in stuff that he was doing. And a lot of people came to visit him from all over the world. And anytime we had a visiting scientist, he'd say, okay, now so-and-so has done some recent work, and he'll tell you about it. So here we were, just graduate students studying physics and learning about the subject, and we'll get to hear somebody's latest work on, some particular area of statistical mechanics, and we make our best effort to make sure that we figured out what they were trying to say and understand it to the best of our abilities. So it's kind of a challenging, and also kind of reinforced the idea that, research is something that you can understand, and you should pay attention, and you can understand it. It's not something somewhere else. Well, after all, it was a graduate program. And so I had a great time. So but then Belfer School, graduate school, died for financial reasons, so it was closing. So Joel moved to Rutgers. So I moved with him to the math department at Hill Center, Rutgers University. And I finished my PhD work there, even though my PhD is from Yeshiva. And the person I collaborated with there is Shelley Goldstein. So I worked with Joe Leibowitz and Shelley Goldstein. I would have some ideas. I'd go back to him and we'd discuss. So it was like he was, because my advisor was a very busy man, so he was the one who was more instrumental in working with me. And so one of the interesting things working with Joel was that, so he always got involved with visiting scientists. There were always people coming from, other universities here, from Berkeley or from somewhere in Rome or some Paris. So, and he always called his students and said, okay, so-and-so is visiting, so come to my office and they'll tell us about what they're doing. So you always got to hear about new work that was happening, and you were just a graduate student, so you were just always listening to these wonderful things and trying to understand as much as possible. So I want to tell a story about my thesis, which kind of makes some importance. So Joel gave me this problem in non-equilibrium statistical mechanics, and it was a difficult problem, and so there was no real formalism for that developed yet. So I mean, it's very easy to state as a physical problem, but as a mathematical problem, it's difficult. It's trying to show that if you have a system in contact with the heat bath at a certain temperature, eventually it'll go to equilibrium. So any physicist would say that's trivial, it's going to happen, but to actually prove it using statistical mechanics. So equilibrium statistical mechanics was well understood and had a standard formalism, so you could take the formalism and solve problems, but this had very little developed formalism. So for about 2 years, I was just struggling, trying out this, trying out that, and going nowhere. And I knew I had to study ergodic theory, which I did. And then one of the visiting scientists from Italy wanted to talk to me about what I was doing. So I told him, this is what I'm doing. I'm not making much of a progress. So then he said, I've been thinking about these similar problems. We kind of look at it this way. So, that was like a light bulb moment. So, he told me that, and then I started thinking along those lines. And within like a few months, I was able to make some progress on my problem and eventually solve it. So, that's one way that research happens, that you're stuck on something and somebody might just trigger this one idea that just opens it up, and then you just move on from there. And then you can start moving, and once you start moving, you're able to develop new ideas and move on. So, and then I discussed these ideas with Shelley, and we finished. So anecdotally, surprisingly, today I was standing on 72nd Street, coming back, and there was Shelley standing there. I met him. He was coming to a seminar at Columbia. So it was really strange. Okay, so after I got my PhD, I worked for a few years in Ohio State and Oregon, and then came back to New York, to New Paltz. And my work after that has been basically a lot of collaborations. In New Paltz, when I first came, I did some collaborative work. It kind of happened in a natural way. So somebody gave a seminar, and from Albany, some mathematician from Albany gave a seminar, and so I felt like I could generalize the result. So I discussed it with one of my colleagues, and we started working on it together, and so we finished the paper. And another person in my department was working on neural networks, so he gave a seminar, so I went to the seminar, and I noticed that he could prove some convergence theorems that he wasn't thinking about. So I told him, you could do that. So he said, okay, so let's see if he can, tell me what can be done, and let's work on it. So I wrote a couple of papers with him on that. So it's kind of, it's not unusual. That's sort of the way research evolves you see somebody in a conference giving a talk, and you have some ideas. You can talk to them. I mean, not always open like that. Some people may be very protective of their ideas, but in my experience, it's been, at least the people I've worked with, if you have some ideas, you go talk to them, and then maybe you work together and make some, go over it and solve some interesting problems, and so that's a lot of fun. So then I started working with people from all over the place, not all the places there, but I've worked with people in there. Well, unfortunately, nobody in India yet. I've been trying. So the first kind of major international collaboration that I had was with the Italians, because it was my old Italian friends that I met during my PhD days. After like 6 or 7 years after my PhD, asked me, they were working in this new area of interacting particle systems, and they said, and I was also thinking about moving into a different area, because non-equilibrium statistical mechanics was getting difficult and not too many opportunities to do further progress. So they asked me to come visit them in Rome, and they found for me a fellowship for 6 months to go there. So I went to Rome for 6 months, 1 semester, took a leave, and the people who invited me were Enrico Presutti and Anna Di Masi, and they were the people who were kind of leading this new effort in hydrodynamics of interacting particle systems, recently developed ideas and methods. So I went there and so spent a month studying some of the basic ideas. And then Enrico said, okay, here's a problem. Think about it. So I spent like a few months, maybe a month, working on it, and was able to figure it out. And so wrote a paper. And then gave me a more challenging problem to look at. So basically my stay for 4 months there, it was learn a little Italian, work, go home, work, eat some good food, work. So it was basically work. So I'd go to the office, work, and every couple of days you would think about something, work on something, you have some idea. You go to Enrico's office, maybe the other people, he also had visitors from all over, from France and from Brazil and so on. So there may be somebody hanging out, so I go there and talk to him and say, I'm thinking about this problem. Then he'd say, okay, let me call, Maria Eulalia and Pablo, and let's talk. So everybody will come. So we'll start talking, so we start discussing, and so they'll get involved and say, okay, why didn't you try that? Why didn't this work this way? And so it will be just, so you work on something and then have like 2 hours of discussion about what was going on, and maybe it went somewhere, or you got stuck again, then you go back. Or maybe you go back and you struggle with it, and then maybe one of the people who are talking to you there may come back and say, I had this idea about this, maybe you could look at it that way. You try that, and you go back and you struggle with it. So it's, so it's like, it's a lot of pain in some ways, because you struggle and struggle and struggle and doesn't go anywhere. But, at the same time, you don't want to give up because you really want to know. So you keep on trying, but it's nice to have other people around you, because then you could go try out an idea on them, and they would tell you, maybe looks good, maybe there's something wrong there, or you could try a different tack. So that feedback is nice, because it also makes life, so you're not sitting alone by yourself. So it gives you some interaction, and you can work things out. So I got to know a lot of people, other than Enrico and Anna. I met some Brazilian mathematicians and French mathematicians, and we would discuss a lot of things. And so I finished my time there, finishing another bigger paper, and with Enrico. But the other thing I also learned there when I was there was about teaching. So So the Italians, until I think now they do that. So the way they do the teaching is kind of different. So they have lectures and stuff, but the exams are completely different. So for the exams, they set aside like maybe almost a month for exams. So the professors set aside a month for exams. So the students make an appointment. So the students have to make an appointment with the professor at a certain time for a certain amount of hours. And the student comes to the professor, and the professor's office, one at a time. And the professor, so the subject is what was taught during that year, that semester. The professor can ask anything. So you come to his office or her office, and the professor can say, okay, now tell me about this. So you have to explain on the board. So then the professor can say, okay, how about that little variation on that? So can you solve that? Can you work it out? So it just goes on and on for a couple of hours where you have to really, so you have to know your stuff. You have to really know what you learned in that subject. So every little aspect of the subject can be asked. You don't know what will be asked, but they can ask you every aspect of the subject. And if the student doesn't know something and is having trouble, what the professor did was to say, okay, you don't understand such and such and such. Here are the textbooks where you should have studied these things. Go to the library and study and make another appointment. So the student goes away and comes back after a week, having studied and learned the stuff, and then repeat the same procedure. So what I really liked about this procedure was that it didn't focus on whether you could play some game and get a grade. The focus was really on really understanding what you were learning. And if you didn't learn it, it was not a big deal. Just go back and learn it. Go try it again, learn it, come back. And the student can talk to anybody they want. They can go outside, talk to their classmates. They can talk to anybody they want. There was no restrictions, because in the end, they have to come to the board and explain it so that the professor can know whether you're just, you cannot fool, because they have to really explain the stuff. So I thought it was a great system. Labor intensive, because they spend about a month. That's all they do. All these professors who are serious researchers give up that 1 month, and that's all they do. So they'll say, I have exams, so I can't do anything. So they'll be doing that. And so you'll see students lined up in front of the hall, waiting to go in. So that's something. So when I came back from Italy to New Paltz, I said, I should try this here, right? So I'll go back to this later. So I said, okay. So I'll slightly modify it. So I said, I'll make up groups. So I didn't want to make the final exam that way. So as I made up some group projects, so where I had challenging problems, I'd give them. And I said, okay, you can work in groups. Go ask anyone. If you want to ask another professor, ask another professor. Ask your uncle, ask anyone you want. And then you have to make an appointment, and you have to come to me. And one at a time, you have to go, and I'll ask you whatever I want on the project. I give you these problems. I can ask you every corner about this problem, and you have to explain it to me. And if you have trouble solving it, you can go out, consult some of your group mates and discuss. And if you think you've worked it out, come back and talk to me again. So I made that system a slightly modified version, but also gave them the support of a group. And what I noticed was that this was something, for my students, it was kind of strange. And what I noticed was they really learned a lot. They learned a lot. And they even said that they learned a lot, but they also complained. So they said, what do you mean? This was a 3-credit course. You're making me work like it's like a 6-credit or 7-credit course. So, but, so the fact was, they also said at the end of the course, at least a sizable portion of the class said that they actually learned a lot from that class. So I think that's a great system to teach, but it's heavy in terms of how much time it requires. And also in the US, it's a difficult thing to pull through because there's all kinds of... So after a while, I gave up on it. So it was difficult to run it, and there was a lot of tension. So among students, because I was the only one doing it, so I was kind of standing out as a singular person, so I could only do it for a certain while. But that's something I got from them, and so how the research kind of went into teaching, because, I mean, for me, that's kind of like doing research, because you're really interested in learning the stuff, and you really, the professor is not there to say, okay, you can't learn it, saying that, okay, you didn't learn it, go back and learn it. We can talk about it. You can go talk to anyone you want. It's not like, you just have to learn it in a limited amount and then have to repeat it. You can go, the main goal is for you to really have a deep understanding of what you're learning. That's the main, what else is there to, and that's why you're in college, to learn, right? So in Italy, I met two of my Italian colleagues, Pablo Ferrari and Mariola Leavares. So after I finished, came back here, they invited me to come to Sao Paulo to do some work. So I went for a couple of months in the summer and did some work with them. And they're both big probabilists and have deep probabilistic insights. At that time, I was a mathematical physicist working more from a mathematical physics perspective. So I started working with them, and I learned to think more like probabilists, and they helped me think in that kind of way. So that was a great experience, and we wrote a couple of papers. And so, I mean, all these people have become my close friends. So all the collaborators are now my close friends. So Pablo's now in Argentina. Mariola is still in Rio. And then I went for my sabbatical. I got my sabbatical, and I wanted to. I was away. I was in Italy and then in India, and so I wanted to work on something different. And so Joel, my old thesis advisor, said, "Why don't you work on this problem?" And I think Claudia Newhouser is also thinking about this problem. So I never met Claudia. So she was in Minnesota. So I just sent her an email and said, no, we were supposed to be working on this problem. So I was sitting in somewhere in Rome or India and working on the problem. She was sitting in Minnesota and working on the problem. We'd never met before. So this was a different experience. So we just go back and forth. We'll send information about, I thought about this. What do you think? And she'll send me some information. That works. This doesn't work. And so we worked back and forth without seeing each other. And by the end of my sabbatical, we finished the problem and came back, and I met her. So I met her at the end of the paper. I finally came by. She was visiting Princeton, so I went and saw her and saw who she was, and we wrote the paper. So that's kind of an interesting experience where research went on, even though we didn't see each other. But I prefer situations where I actually see the people. And well, now I know Claudia well now. So when I came back after that, so in a different direction. A young person joined the department. He was a computer scientist, Suresh Singh, and he said he was interested in some questions. So he was interested in computer science problems, broadcasting and gossiping problems. So broadcasting problem is where somebody has some information and they want to share it with everybody else. So computers, for example, that somebody could be a computer. And so what would be the most efficient way to achieve that? Right? That's in various situations. He wanted to understand that in a setup where there was spatial randomness. Since I was kind of into that kind of stuff, so we started talking about it. And so we started discussing. So this was kind of a completely different thing to think about, because he was coming from a computer science way of thinking. So we started thinking about it, and together, so he would go one way, I would go another way, and we kind of come together, and we managed to do some interesting problems. And so this problem actually led to another problem, a purely mathematical problem that kind of started here. So that's the next one. So the problem that it led to is so I said, okay, so you're studying problems where people are just sitting somewhere and there are entities trying to communicate this secret, let's say. But in real life, people move around. So what if they're all moving, everybody's moving around, and this one person that's got information wants to tell it to everyone. So they can only tell it to somebody if they're reasonable distance from them. And so they have some chance of transmitting the information when they come close enough, and they have a certain chance. So how would you model that? So I made up a model for that, and it turned out it was a much more difficult problem. So I started going to various, any meeting I went to, I would say, there's this problem, what do you think? You know, you have any ideas, any suggestions? And everybody basically thought about it a little while and said, it was difficult, too difficult. So I started, I would go to seminars I'm still going to seminars at Courant, NYU. So I started talking to people there. And I started working with Chuck Newman, who's a professor there, about this problem, and we had some partial results. And Fabio is another person from Sao Paulo, and he came to, I had met him and I'd been there before, so he came to Cornell, and so he came by to visit me. And so we started discussing this problem. So he was also thinking about it. So when he went back, and when Chuck and I had more or less had some partial results, that summer I was going to Brazil for a conference, and then he told me one of his PhD students more or less solved the problem. So I found out how they solved it, but they solved it for a certain simpler version, so some initial conditions which were deterministic. So I'd been thinking about a more general randomized initial conditions. So we decided, okay, now how would you do that one? So then we wrote a paper together on how to do it in a random environment. And so he was the frog that's called the frog model, that problem. And then what happened with that is I kind of moved away from it after that, but Fabio kind of took it over, and he's written a huge number of papers, and he's kind of expanded on that idea and into that area, and so he's become a big, a lot of work is being done in that area. So that kind of evolved into its own thing. And so then I wanted to go back to particle system things I was working on in Rome, and hydrodynamics of particle systems, which is an area. So my friend Elaine Sada in Paris asked me to, so when first time we met, we were in Italy, when we were in Italy when I first went there. She was also visiting, so I knew her. And I'd gone a couple of times to give seminars and things. But she said, we should do something together. And we found this problem that was kind of different from what people were studying and seemed difficult to solve. So we started working on it. And after a while, we had some breakthroughs and seemed to be making progress. And then, let me skip to that. Okay, so then, so it was interesting because we finished the paper and submitted it to a journal. And it came back from the journal, and the referee said, well, there's one of the referees here has some really nice ideas that you could make your paper better. So when we looked at the idea, and it was really elegant, and so we had solved the problem, but this idea was really elegant. So we said, we really want to write a paper with this referee. So we said, we want to make him a co-author, and we want to write a paper because his idea is so nice, we want to put it in, and since he had this idea, we want him to be one of the co-authors. So then, of course, he revealed himself, and then we made him into a co-author. We talked to him, and then somebody else refereed it, and it got published. And that's Christophe Bahouduran who did that. And after that, we've been working together, doing one thing after the other in a similar vein of those types of problems. And it's been a wonderful collaboration because we all enjoy talking to each other and discussing with each other. But they're both in France. I'm here, and we just and then recently Tom Mountford, who's in Switzerland, who's also interested in this kind of problem, started working with us. So we kind of hang out. In the summers, I would go there and spend a month and work intensely. Elaine would come back here for 2 weeks in like a fall, and we'd work intensely. And then in between, we'd kind of throw back and forth throw one idea there, and then it comes back, and you think about it, and then so it kind of germinates for like 3 months back and forth, and then something comes out of it. So let me go back to the other thing. So my next sabbatical, I went to, since I was going to seminars at Courant, I said, okay, I'll go to Courant for sabbatical, not go away from anywhere. And I already knew Chuck. We've been working on, so that's Chuck, working on this frog model problem, which didn't go anywhere. So he suggested a problem about some continuum limit problem. And Renato Fontes was his former student who had gone back to Sao Paulo as a professor. And so he was also visiting. So we said, okay, we'll work on this problem. And we managed to do some nice work during that period. And the work that came out of it is called the Brownian Web. And it's kind of become a very popular item now. So, and I've been able to work with Chuck has had like about 3 or 4 graduate students at Courant doing PhD with him in this area. And I've been working with them also. So it's like, even though I'm at New Paltz, I spend a lot of time working with them and collaborating on work with them. And so we've written a lot of papers together. Some of them with Renatos and some of them with the other graduate students. And we've done a lot. And it's kind of wonderful to work with Chuck because he's a very relaxed person. And he brings in kind of, his PhD is also in physics. So he brings a kind of physics and math background. So he thinks in that kind of way, and we kind of have a kind of connection there. So we will go there. So the way it works is we'll go there, and so maybe the grad student comes in, or sometimes doesn't come in. Then we'll just sit there and we say, okay, how do we understand this thing? And then so we'll just go throw ideas back and forth, and something works. So then maybe Chuck says, oh, that seems to work. Or I'll say this seems to work. So then we just kind of slowly, so the way it happens is we just build one piece, and then it kind of gets built together, and then it's beginning to look like an edifice. Then you start saying, okay, maybe now we have something here. So it kind of done piece by piece. So you have an overall thing that you want to do, but you have to do it in you have to look at every little part and see if we can, because you know what, we're hoping that you know what should be. Sometimes there are surprises, but then you have to kind of solve each little portion and then put it together. So, or you may have a discussion, and then I'm going back on the bus, and I'm thinking about it, and I have a thought. So then I write back to him, and then Chuck would write back and say, okay, that looks good. Let's talk about it. So we go back and talk. So it's kind of, that's the dynamics in which that works for us. And I think that's not uncommon. I think I'm not unusual in that regard. A lot of people doing research. This is sort of pattern is not, it's I think more or less, it happens in a lot of places, with a lot of people. So, okay, now my last slide, and I'm now doing some collaborative work with Raghu Vardhan at the Courant Institute. And, he's a big mathematician, so I'm happy to be able to working with him. So leave it there. What? Oh, there's some. There was another slide. Okay, so that's this kind of tells you. I think this fits with my view of what mathematics is, and the only thing I would add to that maybe is that to do that with friends in a kind of community is even more fun, more enjoyable to. And it's possible to do that. So it's possible to create kind of beautiful things with friends. So, thank you. Okay, do you have questions?
Whoa. Sorry about that. So you mentioned how in elementary school you sort of got the experience of learning how to think through a problem on your own silently, and then in high school you sort of developed solving problems with other people. But then sort of where along the line do you think you developed the ability to ask really good questions, and what do you think the benefits are of learning those things in that order?
Uh-huh. Yeah, I mean, no, but that's not all we did in the elementary school. That was one class. Okay, so we also did things together. Though I mean, children, it'd be difficult to not do things together. But that was one class. I would just say that's kind of remained with me, this class, because it was interesting. But yeah, we did things together as well in elementary school. Asking good questions, I think I would say even in high school and early in college in India, I was lucky enough to be with the cohort where we were all interested in understanding things. So we would ask each other, and we would ask each other questions, and we would discuss, and we would say, what do you think this is? What do you think that is? And so there was, interest in knowing things. If you have interest in knowing things, then, you have to learn to ask good questions, but that's a difficult thing at the high level. When you at the graduate level, asking good questions is, I had some bad experiences, so I know it's difficult because not only do you have to ask, there are lots of good questions to be asked, but you have to ask good questions that you can answer. That's a more tricky thing. So, at least when I started out, I found all these wonderful questions that I wanted to know. But for a while I was stuck and didn't go anywhere. Then I had to learn that I had to ask I can ask, all those questions are good, but you have to find a way to ask questions you could actually have a chance of answering. So that's the more difficult thing to learn in research. Yeah.
I don't want to use a mic. It's too loud. The last time I was here, me and one of the other alums of the education program talked about our current students. I teach middle school and she teaches high school juniors and seniors. And we talked about sort of almost the lack of independence in a way in student learning, at least in our particular experiences. So how would you compare that, or how have you seen that within the university level? Like, is there, I'm trying to think of a better word instead of independence, but at least within your own experience as a professor, how would you describe it?
Well, unfortunately, I have to say that I see similar things at the college level, and especially since I'm in a state system, and things are moving. To my mind, they're not moving in the right direction, and so I try to do what I can, but I think focus more on getting grades and doing things in a very controlled and limited way, and this thing of the goal is really to know things and understand things. There are students who are interested in that, but it's not as, in my experience over the years, I've seen it become less and less.
Did you feel it was different in other countries?
Yeah, I think when I go to France, I don't know, maybe my sample is biased, but I think the people I encounter there and the students seem to be very serious. And the students I met in Italy who were talking to their professors. So it's also the interesting thing is, so imagine being able to trust the professor to do that. The way things are these days in the U.S., in public systems, in my college, for example, they wouldn't trust that professor. What if, so they'd say, the professor could do bad things, and they could give a wrong grade to the student for other reasons. There, they completely trusted the professor, So, there are two sides to it. So the fact that they trusted the professor for the most part, made the professors take their jobs extremely seriously. They thought of themselves as these important people who have this important responsibility. And so, these people who were great researchers were willing to give up 1 month of their time for teaching, so that they could write, a paper in that time. They gave it up. For 1 month, they were sitting there. So, and the society gave them that, that respect, and they reciprocated it. But here it seems to be going, unfortunately, things seem to be going in the opposite direction. It's sad. So, I'm sorry I can't give you good news.
So in terms of research projects, I've heard both like pros and cons of having a group of people that all kind of have a wider range of what they know in terms of being interdisciplinary and knowing some about a lot of different topics. And then there's another kind of grouping that is there's specializers in different kind of areas, and they come together to work on one common project. Do you have an opinion of which you have seen works better, or if different cases, and how in colleges should be preparing their students in terms of engineering jobs or like math or science or any kind of areas to be more specialists or to be more interdisciplinary and know more about a broader range?
Okay, I don't know that I can comment, thoughtfully on that, because I work in mathematics, in a certain area of mathematics. So my collaboration is all with people who are, in my area and close to my area. So when we collaborate, we don't do this portion of the work is done by someone. Even if we do certain portions of the work in the paper, we all know the whole paper. We know every argument in the paper. Everybody clearly understands every argument in the paper, even though one person would have contributed more to one part than the other. But so to answer your question, I think I would think having an overall broad view of the subject, they're both important, but having the overall views has its advantages. So you can kind of see where what you're doing fits in the bigger picture. But of course you should also know what you're doing really well. So so you cannot just say, okay, I kind of know a overall picture, but I don't know. So you have to have a strength in, especially if it's an interdisciplinary research, and whichever part you're contributing, you should be strong in. But it would be good if you're also able to understand. It'd be a much better collaboration if each person understands to the best possible extent, given that they're not in that field, what the other person's doing and how it fits into the project. That's what I would guess. So.
I think that's it.
Okay.
Thank you.
Thank you.
Awesome.